Hi friends, welcome back. Today we are going to solve Leetcode problem 257 binary tree paths. Given the root of a binary tree, return all root to leaf paths in any order. A leaf is a node with no children. So they have given us a binary tree here, and as you can see 1 to 5 is one path here, and 1 to 3 1 to 3 is another path. So I actually took a little bigger example here so I can explain little better. And so we are given a binary tree and we have to capture all the paths starting from a root node going to the leaf node. So all the leaves. So we are going to use a backtracking for this purpose, and we are going to actually start with the root node 2, and we are going to kind of maintain a list like of nodes that we keep visiting uh, on the way. So let's add 2, and we will go on the left side first and then we will go on the right side. So we are going on the left side, we are going to visit root node 7. So we are going to add 7 into the list, and again we are going to the left and we are adding 2 into the list. So as soon as we reach this node 2, which is a leaf node, we are going to capture the list that we have. So we have 272, so we are going to add this 272 into our path, and then we will actually backtrack. So now we are already at the leaf node, so we are going to backtrack to the previous node that we visited, which is 7, and we are going to remove the 2 from the list. And now we are going to go to the right side, right subtree of 7, which is 6, right? So we are going to go visit 6 and we will add a 6 into our list here, and then we will go on to the left side and we are visiting 5, so we will add a 5 into our list here. So this is our list, and once we reach 5, we are again at a leaf node, and we are actually want to capture the path that we have uh, visited so far. So now the path is, as you can see, 2765. So we have this path 2765. We are going to add this into our paths list, and then we will now again backtrack from 5 to the previously visited node 6, and we will go on to the right side, and at the same time we will remove the 5 because the 5 we already have seen now. So now we are going to 11 and we are going to add 11 into our list here. So now again we are at a leaf node, and we have a list now of a path like a 2 7 6 11. So as you can see here, 2 7 6 11 we will add into our output paths list, and we will now again backtrack from 11. So we will go from 11 to 6, and 6 to 7, and 7 to 2, right? So now 11 we will remove, 6 we will remove, and then 7 we will remove. So now we only end up with a 2 in our list, right? So let me just write it down here. So now again our list become just with one element 2, because other elements we have removed because of the backtracking. So now we are going to visit the right side nodes now. So we will visit a 5 and we will add 5 into our list. Then we will visit next node 9. We will add 9 into our list, and we have 4 on the left side that we will visit, and we will add a 4 into our list. So as soon as we visit 4, we are visiting a leaf node. So we are going to capture this path into our output list, which is 2594. So this is a 2594 added into our list. So this is how we will use a backtracking and a list. So here is the implementation, that same approach that I showed you. Let's just discuss little more details here. So the output we want to return is a list of strings. So I took a list of string, which is a result. uh, then I have implemented this traverse, which is a recursive function here, and we will pass the root first here, and then list of string as a list here, and this is the output list that we are using only to capture the output paths that we receive from root to leaf. So it is list of strings here, right? So the main purpose of this output is only to get the paths out of this function, right? Because the function is returning voids, that's why we are passing a list of string here. So first thing we will check is if root is equal to null, then we will just return. We don't have to do anything. If we reach a node which is a leaf node, then we are going to add the value of the leaf node into the list, and then we will just create a new list from the list. This is required because otherwise the list is on the heap, so it will keep appending onto the original list. That's why we have to create the new array list here, and that new array list, which is actually this new list contains the path from root to leaf, we will add into our output list. That this output list here we will add, and then we will remove the last node that we added. This is required because we are actually backtracking, right? So the last node that we have added, we want to remove it and then return it. So the same thing as I explained here. So for example, from 2, once we are going back from 2 to 7 in the backtrack, then we want to remove that 2 from the list, right? That's what we are doing here. So uh, if we are visiting any intermediate node, for example, we visited 2, then we are visiting 7, right? 7 is an intermediate node, it's not a leaf node. So in that case, we will just add the value of that intermediate node into our list here, and then we will recursively go on the left side of the root, and we will go on the right side of the root, and then at the end we will take out the last value that we added into our list here, right? So this value that we added into our list, we want to remove. This is for the backtracking purpose, right? When we want to go back in the backtracking, then we want to remove the lastly added value. So that's what we are doing here. So once we return from the traverse function, we have this list populated. List is a list of strings, and it has all the paths. So we are going to iterate through the all the paths, and we are going to use a string builder, and we are going to append this kind of arrow actually, because this is what they want us to return, right? One arrow, two arrow, five. So this is what it is doing. We are using a string builder for that purpose. And then we are finally, once we are done for every path, then we are going to add that path into our result, which is a list of strings, right? And here what we are doing is we have that extra arrow at the end that we added here, though we are just taking it out here, because that extra arrow that we added, we are just removing it here. So at the end of the function, we will just return list, and that list will contain all these paths like this. So I took an example, which is this example that given to us. So let's quickly run through the code. So as you can see, the code is working fine. We are getting the correct output, and we are going to submit this solution now. Okay, so the solution is getting accepted. um, so this is how we are going to get like all binary tree paths which are starting from the root and going all the all the leaves of that tree. So this is how we can use a backtracking and a linked list, or list actually, for the implementation. So I hope you like this video. If you like this solution, please hit the subscribe button and click on the like button. Also click on the bell icon so you will not get like missed on any future videos that I keep posting. Thanks for watching the video.